In this video, we will be looking at two related standards from the interpreting functions and building functions domains. Students are expected to understand that all sequences are functions that can be written explicitly or recursively. Using graphs and calculations, students should be able to show how values in explicit formulas, recursive formulas, and functions define the same sequence. The domain of these sequences falls in the set of natural numbers. Students are expected to write arithmetic and geometric sequences that model real-life situations both recursively and explicitly. Students should also be able to translate between the two forms of a sequence. Finally, students should be able to associate arithmetic sequences with linear functions and geometric sequences with exponential functions. In the student clips throughout the rest of this video, watch for some of these common misconceptions. Also, watch as students engage in the standards for mathematical practice to correct some of these misconceptions with little guidance from the teacher. In the following clip, students are working on a task called microbial growth. In this task, students engage in all aspects of the two standards represented in this video. In the clip that follows, students are trying to determine the type of function that represents their arithmetic sequence.
What function is connected to a linear graph? What is the name of that function? Is it, I'll give some clue, is it a quadratic function or exponential function? Is there any name for it?
Exponential.
Linear function?
Exponential.
Do you agree there?
Yes.
No?
Why should it be exponential? Because
That's geometry, it's arithmetic.
this is arithmetic, so wouldn't it be a linear function? But if it's exponential, you'd be constantly multiplying by what we're just adding more. It's a linear function.
Pause the video here and discuss the student clip you just watched with your team. What did you notice? How were the students engaging in the mathematical practices? What questions do you have for the teacher? What questions do you have for the students? What might you have done differently? In this next video clip, students are working on a task called Count the Quilt Blocks. In this task, students engage in all aspects of the two standards represented in this video. Watch the students in this group grapple with the idea of whether or not to connect the points on their graph. Listen to their reasoning. It starts with the girl in the lower right part of the screen sharing that she can find a y value for any x value. She even shows us with her calculator. By focusing the students back to the context, they are able to make sense of the math in order to correct their own misconceptions. What's this problem all about? What did you start with? The very first thing we looked at.
The very first thing we looked at was, the very first thing we got was the box. The box.
Yeah, what are the boxes all about? What is
It's the quilt blocks, right? The unit square numbers, how many are in each figure number.
So always keep that in your mind. We're talking about quilts. So now go back to your graph.
Oh, you can't have a no. Yeah.
So what question are you trying to answer?
Oh, we're trying to answer.
And what is it? What is it?
Connect the points on the graph.
So should you connect the points since you're talking about quilts?
Well,
You gotta
can
figure
you
it out.
have half a number of points? Well, because if you connect it, that means if you use that number in between 5 or 6, then you would get that. So yeah. Right. Because if you have 5, you can't have that for right? Yeah. Because you won't be able to get half the football. It's not so you have
So you can get a number on your calculator, right?
yeah. But you can't have that
As actually, like,
yeah, right?
So you're looking to me to say, yes, you're right, or no, you're not right. I want you guys to convince yourselves that you're right. And when you can do that, then you come back and talk to me. So did you convince yourselves yet?
somewhat.
Somewhat, so what's the deal?
We can't have a negative of this, because no matter how far you get down or negative, you're still gonna have 0. But you can't actually have half of a full block because it's a unit square. You can have half a unit square. All sides.
So what's the verdict? Can I make the points? No definite. Okay.
Because even though it's possible, you still don't because of the pattern.
Pause the video here and discuss the student clip you just watched with your team. What did you notice? How were the students engaging in the mathematical practices? What questions do you have for the teacher? What questions do you have for the students? What might you have done differently? In this next clip, listen to students as they try to form an explicit rule for the geometric sequence. They found something that works for most of the terms, but they struggle to apply their rule to the first term.
And then 180, it would be 5 times 2 to the 4th power. So you get 40, you do 5 times 2 to the 3rd power. And to do 20, you do 5 times 2 to the 2nd power. And finally, you get 10, you do 5 times 2 to the 1st power.
So you said all the numbers in terms of 5 and 2. How do you say the very first number also the same way?
5 times 2 to
A1 time, no. 5 times 2
Look at-
to the 0 power.
No, because that would be 0.
Oh,
5 times nothing.
5 times 2 to, no, they can't do 0 because then it doesn't equal 0. 5 equals 5.
A1 equals 5.
You
Just the
can't
first
change
term.
the rule for just one term.
5 times 2 to the 0 power? Because anything to the 0 power equals 1.
Yes. 5 times 2 to the 0 power.
Pause the video here and discuss the student clip you just watched with your team. Finally, as we wrap up this video, take some time to reflect with your team on the following discussion prompts. First, what kinds of questions did you hear the teachers ask? Were they leading questions or were they less helpful? Second, did you notice students taking risks? How do you think the teacher fostered this? And finally, students in these clips were engaged in several of the SMPs. Talk with your team about which ones you noticed and how to engage your students in these practices.